Hello everyone, myself Anshpreet Singh,
And myself Maulik.
and today we will be presenting task 7.2, that is communication between two robots. Coming on to the brief overview, the objective of the Bluetooth controlled car's digital twin project is to create a virtual replica of a physical car and its surroundings using a blend of software and hardware elements. By developing a digital twin, users can simulate and interact with the car's behavior, manipulate its movements, and monitor its environment without directly interacting with the physical vehicle. The project incorporates an Arduino Uno microcontroller as the central control unit for both the physical car and its digital twin. The HC05 Bluetooth module facilitates wireless communication between the physical car and a mobile device or central controller, enabling users to send control commands and instructions. To establish a wireless connection between the physical car and its digital twin, a 433 MHz RF module is utilized. This allows for the exchange of data and information between the two entities. By combining the Arduino Uno microcontroller, HC05 Bluetooth module, and 433 MHz RF module, the project enables seamless wireless communication between the physical car and its digital twin. Here are the slave and master prototype for our project. Component required for the project includes an Arduino Uno R3, a HC05 Bluetooth module, a RF module, and a L29A10 motor driver.
Data input through RF module. In this slide, we will discuss about the data input. Firstly, the input is sent through the Arduino R3. It sends the data and a transmitter receives the data. This data is sent through the frequency of the 433 megahertz and RF module receives the signal. Receives the data is sent to an Arduino R3 and output is produced. Here is the circuit diagram for the transmitter circuit. You can have the brief look of the circuits and the pin used. Now coming on the circuit diagram of the receiver module, here you can see the diagram briefly and the pin outs.
Coming on to the code description for transmitter module, we have first installed the virtual wire library. It provides the functionality for wireless communication between the robotic car and the central device using an RF module. We begin with the setup section where we initialize the necessary components and define the pin modes for motor control. Here we set pin 5, 6, 10 and 11 as outputs to control the motors of a robotic car. These pins will be responsible for determining the movement direction. Next, we configure the serial communication at a baud rate of 9600. This allows us to receive instructions and commands from a central device. Now, let's take a closer look at the main loop. This is where the car continuously checks for incoming serial data. Inside the loop, we use the serial available function to check if there is any data available for reading. If there is data available, we read it using the serial read function and store it in the input variable. Once we have the input, we perform different actions based on its value using if-else statements. Next, we have the movement functions to control the car's movement. For example, we have a void backward function to move the robot backwards. Similarly, we have forward, right, left, and stop function for the directions of our car.
Now code description for the receiver module. So this is an code for a remote control car using a virtual library. The movement are controlled by wireless signals received through a radio connected to the Arduino board. The setup function initializes the motor control pins and the virtual library for wireless communication. The loop receives the data packets from the radio receiver and checks for the first character in the packet. Depending on the first character in which is he received in the packets, the car will move in the specific direction or stop. The forward, backward, left, and stop function are used to control car's movements by setting up the appropriate pins to either high or low. Overall, this code enables wireless control of a remote controlled car. For example, how the Arduino board and virtual library can be used and controlling physical devices.
Now, here is the physical demonstration for our twin robots.